All right, so today we are doing 10-7, which is our first set of word problems. We're working on job and time problems, some distance problems, and just some translating, some general translations. All right, 10-7, work and distance problems. All right. There's two ways to do these types of word problems. I'm going to show you two different ways. The second way is not that much more complicated. But I also have another easier kind of way. So if they're basic and there's not a lot of differentiation in the time or the rate. So here's how it goes. It's job over time plus job over time is equal to job over time. This is when, like, if I grade the papers, it takes me a certain amount of time. If Miss Sophia grades the papers, it takes her a certain amount of time. But what happens if we do it together? We're going to both do it faster, right? Now, obviously, she's much faster than I am. But still, doing it together would be faster than her doing it alone or me doing it alone. So, Jeff can paint a room in 4 hours. That means he can do one job. This is Jeff. Jeff can do one job in 4 hours. Okay? Plus, it takes Hal 5 hours to paint the same room. He's doing one job in 5 hours. How long will it take if they work together? Is equal to one job in I don't know how much time. Now, what would be our common denominator? Jacob? What? 20x. So I'm going to multiply everything by 20x. Okay. Now, when I distribute here, what am I going to be left with? Yep.
5x.
Good. When I distribute 20x here, what am I going to be left with?
4x.
When I distribute 20 here, what are we going to be left with?
20.
Oh, sorry, 20x? Yeah. I'm going to be equals 20. So that becomes 9x equals 20. Divide by 9, and x is equal to 2 2/9 hours. Now, what does that mean? X is equal to 2 2/9 hours. Make sense of that, Arun? Okay. They can paint the room in 2 2/9 hours. Okay, questions there. Together, they can paint it. Now, if I do it the more complicated way, I set it up like this. It's work rate times the mixed time equals my work done. I'm comparing Jeff and Hal. Now, work rate is your job over time times the mixed time together. Okay? So what is Jeff's work rate? Yes?
4 hours per room.
Set it up the way I set it up here. What is Jeff's work rate? Look at how I wrote it.
104.
One job in 4 hours. What would Hal's be? Right. Now, do we know the mixed time? So we write x. Multiply across. 1/4 x. 1/5 x. Remember, we multiply across. And what do we do going up and down? We add, just like before. Equals 1 complete job. So basically, I'm saying Jeff's time plus Hal's time equals the complete job. Right? So now what you've got is the equation 1/4 x plus 1/5 x equals 1. Now, what do you think we're going to clear the denominator with this time? Somebody I haven't heard from? Okay, we're going to multiply everything by 20. And then, in the first one, what will we be left with? 5x plus equals 20. Which, again, is 9x equals 20. Divide it out, because once we're in these situational problems, real-world problems, nobody knows what 29 hours is. So change it to the mixed number. So if they work together, it will take 2 2/9 hours. Clear? Huh? But we're going to use both. We're going to use this one more because you'll see. For this one, I want you to try it on your own. You can choose either one. Do the easy way. If you want. If you want to do it the other way, that's fine too. Pause the recording. Is anybody still working? All right, so we are doing job over time plus job over time. It's one pool in 10 hours plus one job in 6 hours equals one job in X hours. What am I clearing this by? Yeah. Good. Would it have mattered if I did anybody do 60x? Okay, let's see if it works out the same. It doesn't matter. I'm going to end up with a 3x, right? I'm going to end up with a 5x. And I'm going to end up with equals 30. So see, you should be at the same point right here. And x is equal to, it goes 3 times. I have a remainder of 6 over 8, which is 3 3/4. Now, what if I want to convert that 3/4 to minutes? Okay? How do I convert 3/4 to minutes? Sam? Right. Aren't we doing 3/4 of an hour? What does of mean in math? An hour is, I can write it as 1 hour, or I can write it as 60 minutes. 4 goes into 4 once. 15, 3 times 15 is 45, and I'm left with minutes. So it's 3 hours, 45 minutes. Or 3 3/4 hours. Okay? It depends on like how they're asking you. Yeah.
Well, I thought it was.
So the question is, how long will it take if you put both hoses in the pool? Okay? All right, next one. If I did it, you can look at how, if I do it the other way, 1 over 10 times x is 1/10 x. 1 over 6 times x is 1/6 x. And then we'd clear by 30. Okay. Now, if it's not, in this problem, it's a little bit different. So I'm comparing John and Sam. I'm still doing work rate times time. Mixed time is equal to the work done. I'm comparing John and Sam. What's John's work rate? Jake, is it Mark?
80 minutes.
But his work rate, remember, work rate is job over time. What is it?
1 over 80 minutes.
1 over 80. What is Sam's work rate? Sam. Right, we're going to have to convert that because I have hours and minutes. So I'm going to have to convert to the minutes because 80 minutes is hard to convert to hours. Now, do we know their mixed time? But they do work for a period together, right? The time they work together, let's call that X. But what else do we know? Yeah.
John has X plus 30 because he works for himself.
He also works an additional 30. So as I multiply across, I get 1 over 80 X plus 30. The other one is 1 over 120 X plus 30. Is one complete job. Yeah.
Why is it X plus 30 for Sam too?
Oh, sorry. That was a boo-boo. 120x. Now, there's our equation. Okay? Okay, now, I can put it here. I'm going to show you something. Everybody pay close attention. Before I told you, just distribute and then we'll clear. But I'm going to show you how to clear before you distribute. Got this, Jack? Okay. Now, remember what I said about terms? We know it's a different term when it's separated by a plus or a minus sign. So what I have here is really one term plus another term equals a third term. Are you guys good with that? Do you understand how that's all one term, the first part? So what are we going to clear by? What's the common denominator? Sam? 240. So I'm going to multiply everything by 240. Okay, now, when I distribute here, I only distribute once to that term. Okay? And 80 goes into 80 once and into 240 how many times? 3 times this, right? So I end up with 3 times x plus 30. Then when I distribute the 240, 120 goes into 120 once and into 240 how many times? 2. 2 times what? 2 times 1x, so it would be 2x equals 240. I'm doing this here. Did you understand how I distributed and cleared? Okay. So now I get 3x plus 90 plus 2x equals 240. I get 5x plus 5x plus 90 equals 240. Subtract 90, and we're left with, you guys should be taking notes as I'm doing this, not just watching. X equals 30. What does that mean? Jack, what does that mean? Go back to the question and the problem. Answer that question. It will take 30 minutes longer to complete the job. Okay? Questions? All right. So, oops. All right. Wedding cake. Same thing. We're comparing Julie and Marty. I've got work rate times time equals work done. Why don't you try this one on your own? Pause the recording. See if you can set up the boxes and then give me a thumbs up. And we'll just double check that you have the correct box work. All right, so Alex, what is Julie's work rate?
8 hours.
And so how am I going to write that?
1 over 8.
Good, 1 over 8. How do I write Marty's?
1 over 10.
Good. Now, time. If Julie and Marty work together for 4 hours, how do I show that? 4.
X.
No, 4 for what?
4 for each.
Yeah, they each work 4 hours. Now, how long will it take Julie to finish the job alone? How do I imply that in the equation?
Equals X.
No. How long does it take Julie to finish the job alone? How long implies, does it imply work, time, or work done?
Time.
Good.
So you multiply 4 by X.
No. I'm doing, I start at 8 o'clock and she starts at 8:30. Okay? And we both go till 9. How much time did I work?
An hour.
An hour. But how much time did we work together?
Half an hour.
30 minutes, right? So how would I show my time compared to hers? We both did 30 minutes, but I did what?
Plus 30.
So she's doing, how would I show hers?
So you do plus X.
Plus the X. You got that? Because hers is additional time. She's working the 4 hours plus she's working more. Now I multiply across 1/8 times 4 plus X. Multiply across. We get 4/10, right? And it equals, if I add going up and down, what's it going to equal? 1 complete job. Are you good with that? So now here's my equation. Pause it if you want to try and finish it up. All right, so now I'm going to clear by multiplying by what number? 40. Now, on the first one, I'm going to end up with 5 times 4 plus X. And on the second one, the 10's going to cross cancel, and I should have a 16. And what does that mean, 4/5 of an hour? How do I figure out what 4/5 of an hour is? And what is 4/5 of an hour? Make sense of that, please. Jack, how do I figure that out? What is 4/5 of an hour? Good. Of means times. Okay. It goes once. It goes 12 times. It's 48 what? Minutes. And what is 48 minutes, Jack? Julie takes Julie an additional 48 minutes. Okay? All right. Distance problems. Don't freak out. What do I put on the top row before I do anything? Rate times time equals distance. Distance equals rate times time. Okay, what am I comparing on the left? What am I comparing on the left? 2 planes. How do I differentiate them? Good, perfect. Okay, now I'm going to start filling in items. Okay, the westbound plane travels 900 miles. So that would go under where? Distance for west. Good. The eastbound plane travels 150 faster and travels 1,200 miles. Where does the 1,200 go? Okay, how do I show that the east is going 150 faster? Ilani?
1 over 150 in the rate?
Mm-mm. It's going faster.
Oh.
Alex?
The x plus 150.
Okay, but I think I would call it R plus 150. Right? And what would we call the rate of the slower one? R. Now, it really mentions nothing about time, right? So what's happening is they both leave. One, they're leaving at the same time. One's getting to here, 1,200 miles, and one goes to 900. So what does that tell us about time? Liam?
That one's going faster than the other.
That's not time. Faster is speed. Same time. Right? Boom. We both leave. Where are they now? Right? One's going faster. Okay? Okay, now, going back to my PowerPoint here. Do you guys understand that? Now, distance, we know that rate times time equals distance. And since both times are equivalent, that means they should be equal, right? If they're the same quantity, they may be written different. How do I get time alone in the formula? What would I do to get time alone? Yeah.
Divide by t.
Divide by t. Oh, divide by t to get time alone? Divide by r, right. So is it not true that we can say that t is equal to distance divided by rate, right? Now, I can say for the west plane, what would the time be equal to? What? Somebody? 900 over r. Is that a true statement? And what would the time be for the east? Yeah, and if they both equal t, can't we set them equal to each other? Right? I think that's the transitive property. If this equals this, and this equals this, if this equals that, then this is equal to that. Okay? And now we can use our cross products. R times 1,200 equals 900 times R plus 150. And we can distribute. One student said to me, can I divide everything by 100? Absolutely, I can divide both sides by 100. I can probably do it mentally. Right? 9R plus 1350 equals 12R. And we solve it and finish it up. Divide both sides by 300. And we get R equals 450. Now, what do we do with that? What do we do with that? Yes.
You plug it into r times t is equal to 900.
I don't need to plug it in there because what is the question asking?
Find the speeds.
Don't forget that. Always go back. So what is...
You do r plus 150 for the east, 450 plus 150 for the east one, and the west one is 450.
Right? So it's really the west is 450 and the east is 600. Okay, questions? Okay. Want to try one more? It's exactly the same way, different scenario. Rate times time equals distance. We're comparing Anne and Mark. Pause the recording and try and do this one. I'm just going to post what should be in the boxes. So, I've got R. We don't know. We know that Mark goes r plus 1.5, and he's traveling 6 miles. And we know that the time is the same. How long did it take both of them? They're leaving at the same time. It implies it is the same time. Now remember, distance equals r times t, so we can set it up as time is equal to distance over rate. And if they're the same time, okay? Now pause it and finish. Okay, so we know that Ann should be what? Time is equal to 3.75 over r. We know that Mark is 6 over r plus 1.5. We can set them equal. That's going to be some ugly math. I think I would definitely switch them to fractions and set it up as 3. I would personally do 3 3/4 over r, because really, what does that work out to be? 3 3/4 is what improper? 12, 13, 14, 15/4, right? Over r equals 6 over r plus 3 over 2. I'd rather work in fractions. So 15/4 times r plus 3 over 2 equals 6r. And if I multiply everything by what? What would I do to clear that denominator? Multiply it by 4. Here, oh, wait a second. I would distribute first, because there's 2, right? I would distribute. Then I get 15 over 4r plus 45 over 8 equals 6r. Multiply everything by 8. Left with 30r plus 45 equals 6r. Oh, you're right. 6 times. Oh, yeah, 8. Sorry, I couldn't figure that out. 48r. Subtract it. I just prefer to work in fractions than decimals. So you should have ended up with 2.5, did you? You want me to go back to that? I'm here. I'll finish it up here. 30r plus 45 equals 18r. Subtract 30. I'm doing something wrong. Oh, yeah. That should be 48r. There we go. Subtract 30r. Subtract 30r. 45 equals, is that 18r? Divide by 45. Divide by 18. Divide by 18. And r is equal to, is 18 into 45? Goes 2 times. It's 36. And what do we have left? 4 and 5, 9, 8, 9 over 18, 2.5. And what does that mean? What does that mean? Yep.
Ann's rate is 2.5 miles per hour and Mark's rate is 4 miles per hour.
4 miles per hour. Okay. Questions? Okay, last problem. Okay, how do we show, it's just straight translating, how do we show 4 less than x? X minus 4. But it says the reciprocal of 1 over x minus 4 is, everybody equal, And then 3 times reciprocal of x. How do I write the reciprocal of x? 1 over x, and we're multiplying it by 3. Now, these are fractions, so we've got to think about our restrictions. So, what are we doing? What are the restrictions here? 4 and 0. Okay, and now we are multiplying it. X times 1, x minus 4 times 3. Distribute. I think I might move the, all right, subtract 3x. Negative 2x, divide by negative 2. X is equal to 6. So the number is 6. Okay, what, does that work for both fractions?
Yeah.
All right, and that is the lesson for today. Yes. Now, okay, so I'm coming back here and I'm showing the kids how to do it if I'd set it up the way we did it before. So if I'm just writing down my rate times time equals 3 and 75/100ths, and the other one is T times R plus 1 and 5/10 equals 6. I know I can divide out that R plus 1 and 5/10. Isn't that just dividing by the time? I mean by the rate? Huh? We just did it all in the beginning. So then I get T equals 6 over R plus 1.5. Divide both sides by R. T equals 3 and 75/100ths over R. And then I just substitute in. So that's how I taught you to do it before. This time we just did D equals RT and divided both sides to get the T alone first. And we just went right to setting it up like this. Does that make sense? Okay, that's the end of the lesson.